Okay. Today we are going to be adding and subtracting fractions, and we're also going to look at some complex fractions as well. So, when you add and subtract a fraction, okay, so let's see, if I did like 1/2 and 2/3, do I add that and I make it 3/6 or 3/5? Is that how I add fractions? Just add the top, add the bottom. Is that what I do? No. What do you have to do when you add and subtract fractions? What do you have to do? Yeah.
You have to have a common denominator.
You have to have a common denominator. So how do I do that? What is my common denominator for that? What is my common denominator? What can they both become? 6. Okay? So that is called your least common multiple. Okay? When I list out my multiples of 2 and I list out my multiples of 3, 6 is my least one that they have in common. So then, if I'm trying to make this a 6, what would I do? Multiply by 3, just on the bottom, on the top as well, because you don't want to change the value of the fraction. So I multiply by 3/3, and over here I multiply by 2/2. Okay? So I get 3/6 plus 4/6. Now, how do I add them? Add the top, so 3 plus 4, and then over 6. I do not add the denominator. The denominator stays the same. Okay, so that's how we add and subtract fractions with just numbers. Now we're going to do that with variables, with rational expressions. Okay, so to add or subtract fraction, you have to have a common denominator. Okay, to add and subtract fractions, you have to have a common denominator. Okay, so here's our first example. 7/4x plus 3/4x. Do they have the same denominator? Yes. Okay, so when I add them, I add the numerator, 7 plus 3, and I get 10/4x. That stays the same. Okay, is that simplified all the way? 10 and 4 can be reduced, right? So what does that reduce to? 5/2. So that is my answer when I add those two fractions together. Okay. On the other one, do I have the same denominator? Yes. So that stays the same, and what do I do on the top? Just subtract them. So 2x minus 5. That's all I can do is combine them. 2x minus 5. Can't do anything with it because they're not the same term. Okay? All right, so that's when the denominators are already alike. Okay? Now we're going to look at when they're not. Okay? So to practice, we're just going to practice finding the least common multiple, the thing that is common. Okay? So imagine that these are my denominators. I have two denominators. That's all I'm looking at right now. Is what do I do with those denominators? Okay? So the first thing you're going to do is factor both. Okay, so you're going to factor the polynomial. So you have 4x squared minus 16, and then you have the other one. So 4x squared minus 16, what can I do? What do I always look to take out first? What do I always look for?
Greatest common factor.
Okay, so our greatest common factor. We have the thing that is common in both, and what is that? 4. So we take out a 4, and I'm left with x squared minus 4. Okay? Now I need to factor the x squared minus 4. go ahead and factor that. Thank you. All right. Garrett, how does that factor? Good. So this is a difference of squares. So x minus 2, x plus 2. Okay. Now let's factor this one. So is there anything common in all of them? 6. Okay. So take that out. And I'm left with x squared minus 4x plus 4. Go ahead and factor that. Amber, how does that factor? Okay, so those are my two denominators, or my two expressions in this case. All right, now I have to find what my least common multiple is. What is common in both, okay? So we need, just like when we had the 2 and the 3, we had to try to find something, the least common multiple, okay? So that both of them could be 6, okay? So if I look at just the numbers 4 and 6, okay? If you struggle with finding the least common multiple, maybe you haven't done it in a while, okay, you can list out your multiples of 4. So 4, 8, 12, 16. Okay, those are my multiples of 4. What's the next one? Next one? Okay, so those are my multiples of 4. What are my multiples of 6? 6. Okay, so do I see one that's common? Yes. So the smallest one that is common is 12. So my least common multiple for my numbers is going to be 12. Does that make sense? So if I just look at the numbers, I'm going to have a 12 in it. So this is for the least common multiple of these two. Okay, so I'm going to have a 12. All right. So we're trying to get, for the x minus 2 and the x plus 2, we have one x minus 2 over here, and we have one x plus 2. Okay? You have two x minus 2s over here. Okay, so a way to think about it, not in math terms, is say I have 2 Snickers bars, you have 1 Snickers bar and a Kit Kat, and we want to have the same number of both. Okay, I have 2 Snickers, she has 1 Snickers and a Kit Kat. What do I need to have the same as her? I need a Kit Kat. What does she need to have the same as me? A Snickers. So in total, I need to have how many Snickers? 2 Snickers and 1 Kit Kat. So we're all going to have 3. We're both going to have 3 candy bars. Okay? So I have 2 Snickers. She has a Snickers and a Kit Kat. She needs another Snickers. I need another Kit Kat. Does that make sense? So in this case, we have an x minus 2 and we have 2 x minus 2s. Okay? So in order for us to have the same number, how many x minus 2s do I need? Okay, so in my least common multiple, okay, remember we have the Snickers. The Snickers is going to represent the x minus 2. Okay, so I have 2 of them, right? So there need to be 2 Snickers in there, in the least common multiple, okay? And she has a Kit Kat, so Kit Kat is going to be x plus 2. So she has 1 Snickers and 1 Kit Kat, okay? So in order for us to have the same number, remember we needed 2 Snickers and 1 Kit Kat, right? So what is my least common multiple? I need how many of the x minus 2s? 2. Okay, so my least common multiple is going to have 2 of the x minus 2s. So you can have that as x minus 2 squared or just x minus 2, x minus 2. Either way. Okay, because we want to have, in the end, 3 things. 2 Snickers, and 1 Kit Kat. So I need 2x minus 2's and 1x plus 2. So that's my least common multiple. Does that make sense? So in order for, like, if these were our denominators, in order to make this, I would need to add another x plus 2 in there. And over here, I would need another x minus 1 in order to make them the same. Okay? So that's our least common multiple. I could have 5 Snickers and 2 Kit Kats, but that wouldn't be the least one. Okay? Let's try it again now with an rational expression. Okay? So here are my 2 rational expressions that I'm going to add together. Okay? So the first thing I'm going to look at is my denominators. They're not the same, so I need to factor them. Okay, so my first step is always to factor the denominator. Okay, so 9x squared is one of them. It's not really anything to factor. You just have a 9x squared. Okay, the other one is 3x squared plus 3x. Is there anything common in both?
Yes.
3x. Okay, so what am I left with?
X plus 1.
Okay. So now these are my 2 denominators, this one and this one. And I need to find my least common multiple to find my least common denominator. Okay? So if I look at the numbers, just looking at the numbers first, okay? What is my least common multiple with 9 and 3? 9, because 3 times 3 is 9. So in order to make these the same, all I would need is another 3 over there. Okay? So my least common multiple is going to have a 9 in it. So we took care of the numbers. Okay? Now, this one has an x squared, and this one has an x. So how many x's will I need in my least common multiple?
2.
2. Okay? So in order for us to have the same amount, this one has 2, this one has 1. So I'm going to have to put another 1 with that one to get us 2. Okay? So we just need 2, we don't need 3. Does that make sense? We just need 2 to have the same amount. Okay? Now, this one has an x plus 1, and that one doesn't. So when I'm trying to make them the same, I'm going to have to put another x plus 1. But in my least common multiple, I need an x plus 1. So it's kind of like I have 2 Snickers bars and a Kit Kat. I have 2 x's and an x plus 1. Okay? You understand that least common multiple part? A little bit? Okay. So now let's look at the fraction. So this is what our denominator is going to have to be for both fractions in order to add them together. Okay? So now looking at this one, 7 over 9x squared. I'm going to write this down here. So 7 over 9x squared. In order to get it to be 9x squared, x plus 1, what else do I need? X plus 1, that's the only thing that's missing. So that's what I'm going to multiply on the top and the bottom. Okay, because remember when we multiply anything into a fraction, you have to do it on the top and the bottom so that it doesn't change the value. Okay, so I'm going to multiply by x plus 1 over x plus 1. Okay, so now over here I have x and then 3, I'm going to use the factored denominator. The 3x, x plus 1. So that's what I have right now. In order to make that 9x squared, x plus 1, okay, I've already got the x plus 1 taken care of. Do I have the x squared? No, so I'm going to need another x. Do I have the 9? No, so I'm going to have to multiply by 3x on the top and the bottom. Okay, so now let's simplify what we have. So on the bottom, because they're the same, you can combine, you're going to be combining the fractions. So we have 9x squared, x plus 1 on the bottom. Okay? On this one, we are going to multiply it out so that if there's anything to combine with the other one, we'll have it all already multiplied out. Okay, so we're going to distribute the 7. So 7x plus 7. And then plus, this one is 9x squared, x plus 1. I'm going to go ahead and switch the view here. And on the top, 3x times x is 3x squared. Okay? Now I can add the fractions together. Questions up until there? Any questions? Okay. So now there's no common things that I can combine. So I'm just going to write it in the descending order. I'm going to write it all under one fraction. Okay, so then our last question is, after we combine everything, sometimes there's going to be something that might be able to cancel. So if there's any common factors, is the top factor, doesn't appear to me that it's going to factor. So there's nothing to factor there, there's nothing to cancel, so that's my final answer. So if there's no common factors, it's done. Okay, questions? Just did one, finished one of them. Okay, let's try another one. Okay, I want you to factor both denominators. Factor both denominators. Madison, what did you get for the first one?
2 x minus 1.
Okay. And Michaela Helvey, what did you get for the second one?
X minus 3 times x minus 1.
Okay. All right, so there are the factor denominators. Now I want you to find what the least common multiple of those is, or the least common denominator. That's the same thing. Can use interchangeably. Okay, so find what the least common multiple or the least common denominator is. When you finish, show your table partner and see what they got for their least common denominator. Trying to find what's common. You need to account for everything so that we have the same things. With your table partner, make sure that you account for everything. If it is in one of the denominators, it has to be in your least common denominator. You can't get rid of anything. So if it is there, you have to have it. If it is there, you have to have it. Okay, I'm seeing lots of different things here, okay? We need, so in this one, okay, we have a 2 and we have an x minus 1. Do we have a 2 over here? No. So in order for them to be the same, you're going to need to have a 2 in the denominator, okay? So the 2 has to be there, okay? Is there an x minus 1 over there? Yes, there's only one of them. They already have the same thing, but it has to be in the denominator. You can't get rid of anything. So I have to have an x minus 1. I only need one of them, though, because we have the same number already. If there were 2 over here and 1 over here, then I would need 2 of them. So I know some of you had an x minus 1 squared because you saw 2 of them, okay? But in my least common denominator, when I'm trying to make them the same, I only need 1. Because they both only have 1, okay? And then anything else I'm missing? The x minus 3, that's over here. I have to include that because when I'm trying to make the denominators the same, that one has it, so it needs to be there, okay? So this one has those 2 candy bars, okay? This one has one of them, but it needs the other one, okay? So that's my least common denominator. Do you have any questions? Yeah?
Does it have to go in that specific order, or is it?
No, it doesn't have to go, because it's all multiplied, so it can go in any order. We usually put the number out front, but then the others doesn't matter. Okay? So now, we're going to write down the problem down here, and we're going to leave it, the denominator, in factored form, and we're going to figure out what we need to multiply on both of them. Okay? So we have x plus 2 over 2 times x minus 1. So in order for it to be 2 times x minus 1, x minus 3, what else do I need? An x minus 3. So I'm going to multiply by that on the top and the bottom. Okay, and then I have a minus sign. And on the bottom over here, I have x minus 3, x minus 1. So what do I need now? I need a 2. Okay, so I'm going to multiply by 2 on the top and the bottom. Questions about that? Do you see why that's our least common denominator? Because that's what we were able to get to be the same. We only needed to add a 2 over here, and we only needed to add an x minus 3 over here in order for them to be the same. Okay, now we can combine them. Okay, what I would suggest to do is multiply these things out first before you try to combine. Okay, so this one you're distributing using FOIL, and then the other one just distributing. Okay, the 2. So we have an x squared minus 3x plus 2x, so that's going to give me a minus x minus 6. And then I have a minus sign. And I have 2 going in there, so I have a negative 4x. And a negative 2. Then multiply the 2 in there. Okay, so now I'm going to add, or I'm going to subtract the 2 fractions, okay? When I subtract, remember that this subtraction sign has to go to both of those. So what I would suggest that you do is change it to addition and change the signs over here. So distribute it first so you don't forget. So what I'm going to do is change the signs of those. So now it's all addition. Okay, so we change the sign here. Okay, now we're going to combine our like terms, put it all in one fraction. So we have 2 over x minus 1, x minus 3. And then I have an x squared, I have a minus x and a plus 4x. So that's a plus 3x, and a minus 6 plus 2. Okay, so now my last step is to make sure I don't have any common factors. So, is the numerator factorable? Yes, so let's factor that. What does it factor as?
X plus 4, X minus 1.
X plus 4, X minus 1. So am I going to have anything to cancel? The X minus 1. So I'm going to cancel my X minus 1s because they're in the same fraction, okay? And then my answer is just going to be X plus 4 over 2 times X minus 3. Okay. You are going to do the homework from 2 to 30. We didn't get to the last thing. We're going to finish that up tomorrow. But the homework from 2 to 30 even, those are what you're doing for tomorrow. A lot of them are just finding the least common multiple and making sure that you understand that. Okay?